Hello. In this video we will show you how we repair the Denso common rail injectors at REDAT S.p.A. We will use as an example the Denso injector 095000-580 series. Many other Denso injectors follow the same repairing procedure as they are part of the same family. For instance, 095000-508 series, 095000-560 series, and others which you can see in our catalogue, asking our sales team for a copy or visiting www.redat.com. To disassemble the injector, we use the tools in the REDAT 4010928 toolbox. The disassembled components are placed on the REDAT 4021475 tray. Be careful. It is very important to operate in a clean working environment. We start by holding the injector in the vise, with the solenoid facing upwards. In order to prevent damage to the injector body, we use the 4021400 holding block from the toolbox. We unscrew the solenoid and we remove it, paying attention that the spring, shim and calibration ring do not fall out. We place them in the REDAT 4021475 tray. Then we remove the O-ring. At this point, we remove the valve, checking that the ball comes out too. If it does not come out, we can recover it after having removed the nut. We prepare to remove the nut. This operation can be eased by slightly heating the upper part of the injector body. While the area is still hot, we strike it with a hammer and a strike pin. We manually screw on the 4021290 tool, centering the 3 pins and screwing until it reaches the bottom. Then we unscrew the bush half a turn. With a 15mm hexagonal wrench, we unscrew the nut. Now we can remove the REDAT tool, remove the nut from the body and place it on the tray. When the nut is removed, we can remove the spacer and its orientation pins. We remove the injector from the vise and, before placing it in again, we gently strike the terminal part of the nozzle nut with a hammer in order to ease its loosening operation. We grip the injector body in the vise again, with the nozzle facing upwards. Be careful. During this operation, the element may slide out of the body. We unscrew the nozzle nut, remove the nozzle and the pins, placing everything on the tray. We release the injector from the vise and we turn it, recovering the dowels, the nozzle pin, the spring and the shim. If the element has not slid out yet, we can recover it now. At this point, the injector is completely disassembled. We proceed, taking each component and preparing them for cleaning in the 4021047 ultrasonic tank, keeping them separate to avoid mismatching them with components from other injectors. After the cleaning, the parts are carefully dried and placed on the tray again. We begin testing the solenoid. We check the integrity of the hexagon and of the inner thread. We check that the pins are not bent or broken and that the plastic shell is intact. We also check the working of the solenoid with a tester. The resistance should be around 0.5 to 0.7 ohms. Now all the components undergo a careful visual check to ensure that they are intact and suitable to be put back in the injector. Also, the springs are checked to ensure that they are not worn out. We now check the valve and the ball. Starting with the latter, we check that the rectified face is not ruined and that the overall condition of the sphere is good. In the valve, we check that the conical surface where the ball seats is not ruined, as well as the cylindrical rectified zone which might compromise sliding inside the nut. On the spacer, we check the rectified faces to verify their integrity, with particular care taken for the cross area. We also clean the micro holes and check that they are not clogged. We now check that the rectified zones of the nut are not damaged and that the valve is free to slide inside it. The element must not have scratches or dents on the cylindrical rectified surface. We also check that it slides freely in the body. Once removed, the nozzle nut is replaced with a new one. Finally, we check that the nozzle and valve seats on the injector body are free of scratches and dents. If the injector is particularly dirty on the inside, it is advisable to replace the fuel supply filter. This operation can be performed with the tools in our 4021550, 4021635 or 4021735 kits, which you can also find in the catalogue. Once we have identified which parts should be discarded, we can choose the replacement ones with the help of the REDAT catalogue. We take the new spare parts and prepare for reassembling the injector. For the assembling, we use the REDAT Universal Vise, which is available as reference number 4021580 or 4021615, depending on your choice of packaging. The universal tray can grip all types of injector bodies by simply swapping the blocks, as shown in the pictures. It can be used for both assembling and disassembling the injector. We place the body in the vise, and if the solenoid thread seems ruined, we can rework it with the die present in the REDAT toolkit. We insert the pins and the spacer. In order to correctly place the spacer, the fuel supply hole on the body must match the one on the spacer. Now, we screw the nut manually until reaching the bottom. Then, with the 4021-290 tool and a torque wrench, we tighten it to 70 to 75 Newton meters. We take the valve and check that the ball is in the correct position, which is with the rectified face downwards. We insert it and we check that it is free to move. We insert the O-ring in its seat. Now we prepare the solenoid by inserting the spring and, in the models where there is one, the shim. We place the calibration ring and we proceed to manually screw the solenoid onto the body. Once it reaches the bottom, we tighten it to 10 to 12 Newton meters. During this operation, we must pay attention to the correct orientation of the solenoid. We remove the injector from the vise. We insert the element, checking that it slides freely. We tighten the injector in the vise, with the nozzle end facing upwards. We insert the shim, the spring and the nozzle pin. We locate the dowels and the nozzle. The nozzle nut is screwed manually until reaching the bottom, and then tightened with the torque wrench to 70 Newton meters. At this point, the injector is completely assembled, and we can proceed to test it on the Bosch bench. To test it, we need the backflow kit 1211585 or 4021752 and the nozzle adapter 4021757. These accessories are available in the 4010952 toolbox. Once the fittings are mounted on the injector, we can place it on the Bosch test bench and proceed with the test. We select the injector model we need and start the test. Usually, during the first test, the injector is not calibrated correctly. Therefore, we must try to normalize its flow. In this particular case, the injector has a lower flow than expected. We proceed by removing the injector from the bench and serrating it in the vise again. We remove the solenoid, paying attention not to lose the spring. We remove the calibration ring and we measure it with the REDAT tool MTR-13, which has the part number 4021700. From the 1210490 Denso shims box, we choose a thicker ring than the one previously in the injector. Based on our experience, a greater thickness allows an increase in flow, and vice versa, a thinner one will decrease it. Once we find the suitable thickness, we can reassemble the solenoid and place the injector back on the Bosch test bench. We repeat the test and verify that the flow of the injector is now calibrated. After the test, we print the certification of correct functioning included with the injector, which is now ready to be sold by REDAT as a Rayman injector.